Yes, very welcome to online chemistry classes, my dears. So I'm eagerly waiting to upload the video. So this video, after watching this video, will come to know that what is the meaning of oxidation reaction, reduction reactions, and how do occurs the redox reactions in terms of electron theory. How do you learn the redox reactions in terms of electronic concept theory? So this is the total summary we are going to discuss in this particular class. Okay, let us come about what is the meaning of basically oxidation reactions. Oxidation reactions. Oxidation reactions. There are two kinds of definitions we can say that. Oxidation and reduction reactions have been described in the number of ways, different ways. However, according to the earlier concept, no. So there are based on the oxidation is based on the addition and removal of oxygen or hydrogen. You should remember one point. Oxidation and reduction is based on the addition of oxygen or removal of hydrogen. Otherwise, one more definition you can say that oxidation is a process in which addition of oxygen takes place, or removal of hydrogen takes place. So by that is a point of oxidation and reduction. Okay, oxidation reaction is nothing but the addition of hydrogen, sorry, addition of oxygen, addition of oxygen to a substance, the process in which addition of oxygen to a substance are or removed removal of hydrogen from a substance, from a substance from a substance in a chemical reaction. This is what we call it as in a chemical reaction. Listen, the addition of oxygen to a substance or removal of hydrogen from a substance in a chemical reaction is called as oxidation reaction. So for example, let me do this example. Okay, so H2S gas combined with the sulfur, what happens to that? H2S combines with the let me give one more best example. Okay, for example, oxidation. Look at here, magnesium, if it burns in the presence of oxygen, look at here, this magnesium adding to the this oxygen just adding to the magnesium, and it becomes a magnesium oxide. So here magnesium undergoing oxidation because addition of oxygen takes place. Hence, when addition of oxygen takes place, addition of oxygen to a substance, that substance undergoing oxidation. This is what the definition. And Cu, copper, when you burn in the presence of oxygen, that gets converted into a black compound called as copper oxide. Here copper undergoes oxidation. Next, one more point. This is a familiar example you can remember. That is what rusting of iron. When you expose iron to the atmospheric air, moist atmospheric air, so that iron undergoes rust because iron undergoes oxidation. Why? Because oxygen get added to the iron, then iron becomes Fe2O3, that is undergoing oxidation. So metal to oxide conversion is nothing but oxidation. This is what the oxidation. There is one term, that is what in terms of addition of hydrogen, what is that term? Addition of oxygen and removal of hydrogen. How do you will see that removal of hydrogen? For example, CuO is there. Okay, let me finish that one more example. Next one, reduction. Let us go with the reduction. Okay, addition hydrogen also I'll give. Removal of hydrogen. How can you remove the hydrogen? For example, H2S is there. I am passing chlorine gas to the H2S. Chlorine displaces um, 1 minute, hydrogen HCl plus sulfur when you burn, no? Yes, example is what happens to the H2S when we pass sulfur dioxide through the H2S. Look at here. Here removal of hydrogen should take place. How to remove the hydrogen? Look at here, hydrogen present in H2S gas. When we pass sulfur dioxide, hydrogen gets removed and it becomes hydrogen H2O plus S sulfur. So this is the product what you will get. These are the product. This is what product. So hydrogen removed from the sulfur, removal of hydrogen, that means H2S gets converted into a sulfur, that is nothing but this is what we call as oxidation. Hydrogen getting reduced, hydrogen sulfide getting reduced to sulfur, that is what oxidation. Which oxidation? Look at here. Yeah, that is what's oxidation. And here this oxygen gets adding to the hydrogen. Now hydrogen gets added here. Addition of hydrogen to the oxygen to form a hydrogen oxide. This is what we call as reduction. Don't get confused. Removal of hydrogen from a substance is called as oxidation. Addition of oxygen to a substance is called as a oxidation. But here addition of hydrogen is taking place. Addition of hydrogen with the oxygen, hence the reason hydrogen and oxygen combines to give a water. That is what reduction and oxidation. I hope it's clear. Now let's go with the definition for the reduction reactions. Reduction reactions. Reduction reaction is a reaction in which the addition of hydrogen and removal of oxygen takes place. Addition of hydrogen and removal of oxygen. Okay. Reduction reaction means the reaction, the addition of hydrogen to a substance, addition of hydrogen to a substance to a substance, R over R, removal of oxygen from a substance, oxygen from a substance in a chemical reaction is called as redox reaction. Okay, so that is what, and this is the substance which either gives hydrogen or removes oxygen in the reduction reaction. Any substance which either gives hydrogen or removes oxygen in a reduction reaction is known as the reducing agent. Okay, let us finish first reduction reactions and oxidation reactions. I hope there is no doubt in this. Okay, look at here, this H2S converted into a sulfur, correct? No, H2S gets converted into sulfur. Look at here. So removal of hydrogen is taking place. That undergoes removal of hydrogen is nothing but oxidation. And if I consider from the sulfur dioxide gets converted into a H2O. That means which sulfur dioxide gets converted into H2O? You can see there. Sulfur dioxide get converted into sulfur. I can say not for H2O. Sulfur dioxide converted into sulfur. Look at here, removal of oxygen taking place here. Sulfur dioxide gets converted into sulfur. Removal of oxygen is taking place. I would like to show here. Okay, reduction. One undergoing oxidation, another side undergoing reduction. So this is what reduction. Sulfur dioxide to sulfur is nothing but reduction. Why? Because oxygen is getting reduced. So that is what both the reactions take place. If a chemical reaction in which both reactions takes place simultaneously, then that is what we call as a redox reaction. Redox reaction. Here red represents for reduction. Ox represents for oxidation. What is a redox reactions means? A reactions in which both oxidation and reduction have taken place. The reaction in which both oxidation and reduction takes place simultaneously, then such kind of reactions are called as redox reactions. Reduction reactions are nothing but reactions, a chemical reactions reactions in which both oxidation and reduction, both oxidation and reduction takes place both oxidation and reduction takes place simultaneously in a chemical reaction. Such kind of reactions are called as redox reactions. Both oxidation as well as reduction both takes place. That means above equation is called as redox reaction. Look at here, both oxidation is taking place as well as reduction is taking place. That such kind of reactions are called as redox reactions. Okay, look now, CuO plus H2. So copper oxide, when we pass hydrogen, look at here, gets converted into copper plus H2O. Here copper oxide getting reduced because of removal of oxygen. Copper oxide converted into copper by the loss of oxygen. Loss of oxygen. Loss of oxygen. Loss of oxygen. Loss of oxygen 100%. That is what we call as reduction. Reduction. Addition of oxygen is nothing but oxidation. Removal of oxygen is nothing but reduction. Now look at here. Hydrogen gets converted into hydrogen oxide. That means water. Here addition of oxygen takes place. Addition of oxygen gets added. Hence the reason here this we can say that oxidation. If both oxidation and reduction takes place simultaneously, then this process is called as redox process or redox reactions. Redox reactions. I hope it's clear to you. Now let us go with the term meaning of oxidizing agent and reducing agent. Reducing agent and oxidizing agent. What is the meaning of oxidizing agent? Oxidizing agent. Oxidizing or reducing agent. Okay, let us discuss about the oxidizing agent or reducing agent. First we'll discuss about oxidizing agent. So oxidizing agent basically the substance which either gives oxygen or removes hydrogen in the oxidation reaction is called as the oxidizing agents. Oxidizing agents are nothing but the substances which either gives the substance which provides oxygen, that acts as a reducing agent. The substance which provides oxygen, the substance which provides, otherwise the substance either it gives oxygen or removes hydrogen, then such kind of substances are called as oxidizing agents. Okay, the substance which either gives oxygen or removes hydrogen in an oxidation reactions. So that is what we call as oxidizing agent. So let me take an example. Here above example only I will take CuO plus H2 gives rise to Cu plus H2. Look at here. Here oxidizing agent is which is the substance which either gives oxygen or removes hydrogen in a oxidation reaction. Which substance is providing oxygen to a hydrogen? Which substance which provides oxygen to a hydrogen to convert that hydrogen into water? This is actually oxidation process. That means hydrogen undergoing a oxidation process, but which substance is helping to oxidize that hydrogen? That is CuO. Here CuO acts as a oxidizing agent. Oxidizing agent. CuO undergoes oxidizing agent to convert H2 into H2O. CuO helps to oxidize the hydrogen into hydrogen oxide. So that means CuO is oxidizing agent, whereas hydrogen acts as a reducing agent. One should be oxidizing agent and another should be reducing agent placed in reactant sites. Both oxidizing substance and reducing substance present in reactant site. Now the oxidizing agent is CuO, reducing agent is H2. Okay, so that is the point. Next, let us go with the reducing agent. Means the substance which either gives hydrogen or removes oxygen in a reduction reaction is called as a reducing agent. You can frame the definition from the above. Let us take second example. For example, they may ask you in examination to identify the reducing agent and oxidizing agent, reduction reaction and oxidizing reaction. Okay, ZnO plus C gives rise to Zn plus CO. This is the equation. So what is the reducing agent and what is the oxidizing agent means? You can just remember the definitions. The substance which undergoing oxidation. How undergoes oxidation? Addition of oxygen. Carbon, you can see here, carbon getting oxidizes to carbon dioxide. And right here, the addition of oxygen is taking place. Oxygen gets added to the carbon. Carbon added with the oxygen and it gets converted into carbon monoxide. So that means carbon undergoing oxidation. From where the oxygen coming? From the another substance of zinc oxide. Then this substance is called as oxidizing agent. Oxidizing agent. And if one is oxidizing agent, then another must be a reducing agent. Carbon acts as a reducing agent. Reducing agent. And carbon undergoing carbon monoxide means oxidation. Then zinc reduces to zinc oxide reduces to zinc. Why? Because oxygen is given to the carbon. Zinc oxide being the oxidizing agent, it provides oxygen to the carbon, and zinc oxide gets converted into zinc metal. That is what we call as a reduction reaction. Reduction reaction. That means you're supposed to remember that oxidizing agents undergoes reductions and reducing agents undergoes oxidation. Reducing agents undergoes oxidation. Let us talk now about the third example. MnO2 plus HCl gives rise to MnCl2 plus H2O plus Cl2. This is the chemical reaction. So here you can remember after balancing equations we'll get like this. Yeah, 2H2. Okay, like this. Okay, not a problem. Yeah, this is okay. You can see, you can easily identify now. Okay, remember the substance, both oxidizing agents and reducing agents, always we can find in the reactant sites only. The substance which undergoes oxidation is called as a reducing agent. The substance which undergoes reduction reaction is called as oxidizing agent. For example, HCl is there. Look at here. HCl gets converted into Cl. HCl, hydrogen chloride, finally gets converted into Cl2 gas. That means removal of hydrogen is taking place. Removal of hydrogen is nothing but what? Addition of oxygen or removal of hydrogen is called as oxidation. This is what oxidation process. Next, here you can see MnO2 gets converted into MnCl2. What is that? Removal of oxygen is taking place here. So that is the reason this is what we call as a reduction reaction. MnO2 gets converted into MnCl2 is called as reduction. HCl gets converted into Cl2. That is what we call as oxidation. Oxidation. Otherwise, you can also say that HCl gets converted into water, H2O. This is also called as oxidation. Here, both H2O and Cl2 undergoing oxidized substances. H2O and Cl2 are oxidized substances. MnCl2 is a reduced substance. But here, MnO2 is a oxidizing agent. Sorry, yes, oxidizing agent undergoes reduction, and HCl is a reducing agent undergoes oxidation. Undergoes oxidation. I hope it's clear to you. Not a problem, I think. So few more, some more examples we'll learn now. In terms of electron theory, how to learn the electron, reduction reactions and oxidation reactions. In terms of electron theory, how to study about the redox reactions. Redox reactions in terms of electron theory, electronic concept. What is the meaning of electronic concept? Means number of electrons donated by an atom and number of electrons accepted by an atom is called as electron theory. So oxidation and reductions are the two different kinds of reactions. We can also call them as a redox reactions. How means both reduction and oxidation takes place in a chemical reaction, means we call them as a redox reactions. So according to the electron concept, are described in terms of loss and gain of the electrons. Okay, loss or gain of electrons. So electron theory, based on the electron theory, how can we define the electron, reduction and oxidation means either loss or gain of the electron. For example, oxidation is process. According to the electron theory, what is the meaning of oxidation? Means oxidation is a process. Oxidation is a process in which an atom or ion loses one or more electron. This is a process actually. Oxidation is the process in which an atom or ion, whatever it may be, either it may be atom or ion, it loses one or more electrons. So for this I can say that loss of electron, I can write like this: loss of electron. Listen, what is oxidation means? Loss of electron from an atom or ion. Loss of electron is called as oxidation. I would like to write this in the short form. Loss of electron is nothing but oxidation, LeO. Next, what is the meaning of reduction? In terms of electron theory, okay, reduction is a process, same thing, the process in which an atom or ion gains one or more electrons, so that is, for that I can write like gain of electron. That is what we call as a reduction. For this I would like to write a shortcut, that is what GER, gain of electron reduction. So together I would like to write the both oxidation reduction takes place. That is what a simple word I can use here, LeOGR. LeOGR is nothing but loss of electron oxidation, gain of electron reduction. So let us study now the what is that examples, how to do that, how to identify the reduction reactions and oxidation reactions based on the electron concept theory. For example, look at here. So Na is a element, it has 2, 8, 1 electronic configuration. The outer electrons present in the sodium is 1. And chlorine, there are chlorine atoms two chlorine atoms combines to give a chlorine molecule. I would like to write like this, two chlorine atoms. Now I am passing two sodium metals, two sodium metal donates one electron to the one chlorine, and another sodium metal donates another electron to the another chlorine, and it becomes 2 NaCl. Here is sodium giving electron and gets converting into a plus charge, that is loss of electron. Loss of one electron. Loss of electron is nothing but oxidation. And chlorine gaining that electron, gains electron. That is what we got as a reduction. Sodium undergoes oxidation, chlorine undergoes a reduction, gain of two electrons, a reduction. And after gaining electron becomes a -1 charge. Finally, I would like to write a compound of NaCl is, so compound of sodium chloride is NaCl. Next, one more example. For example, zinc metal we have treated with the HCl. So look at here, zinc having 2 electrons in its outermost shell. That zinc donates 2 electrons to the chlorine atom and displaces hydrogen. It becomes a zinc 2 plus ion after donating 2 electrons, and Cl gains that electrons. Cl gains one electron from the zinc, and it forms a 2Cl plus hydrogen gets converted into a gas. Hydrogen gets converted into gas. I would like to write, look at here. This is the product what you will get, zinc chloride plus H2 gas. But how to express the reaction? Zinc donates 2 electrons and it becomes zinc 2 plus ion. Okay, so that is what I am writing here. Next, hydrogen and chlorine is there. Chlorine gains that electron and connects the break here. So chlorine gains the one electron and it becomes Cl minus ion. And hydrogen that breaks down form a hydrogen gas. Yes, you can see here. There is a thing. Okay. So now let me take one more example. Let me write one more example in better way. When we treat zinc metal with the aqueous solution of HCl, aqueous solution of HCl contains H plus plus Cl minus ion. Look at here. Zinc donates the electron to the chlorine. That means zinc donating electrons, 2 electrons, and it becomes a zinc Zn2 plus ion. And 2 chlorines are not there. 2 are not there. Only one chlorine is there. So one chlorine can accept only one electron. To accept 2 electrons, 100% 2 chloride ions are 2 chloride ions accepts 2 electrons and it becomes a Cl2. Correct? No? So overall I can write here. Zinc undergoing into zinc plus Zn2 plus, whereas this chloride gets converted into chlorine gas. Here this 2 chlorine gas combines with zinc, it forms 2 chloride 2Cl minus. 2Cl minus only here, plus hydrogen H2. So I would directly will say that this is the aqueous solution of H2O, aqueous solution. 2 hydrogens and 2 chlorides are there now because of we have to balance the equation. Zinc donates 2 electrons to the hydrogen and zinc combines with the chlorine, it forms a zinc chloride, ZnCl2, and hydrogen gets converted to H2. So this is the concept. Let me take one more example. Zinc treated with the copper sulfate solution. Copper sulfate contains what? Cu2 plus ions. Okay. Zinc now donating 2 electrons to the copper, hence zinc gets converted into zinc ion, whereas copper gains 2 electrons and it becomes copper metal. So zinc to zinc ion is nothing but oxidation. Copper ion to copper is nothing but reduction. For example, next, Fe plus Zn, Fe plus lead hydroxide, Pb, lead hydroxide or lead chloride or lead nitrate, I would like to take lead nitrate, Pb2 plus. This is aqueous solution of lead nitrate. Lead nitrate. Now, iron donates 2 electrons to the lead. So, hence the reason lead ion becomes a lead metal. After donating iron 2 electrons, iron becomes Fe2 plus solution. So, here iron undergoing oxidation, lead undergoes reduction. That's all. No. Loss of electron oxidation, gain of electron reduction. Yes, there is reduction. This is the process of oxidation and reduction. So thank you. So I am bit slow. Okay.